Welcome to Regis Algebra 2, Lesson 7B. Go ahead and label your notes that and the title, which is Literal Equations and Geometric Formulas. Okay, and don't forget, write everything that I'm going to write here in black. I want you to write on your notes. Anything that I write in another color, you will not have to write. Generally, students in Algebra 2 and Algebra 1 find this concept of literal equations a difficult one when they're first introduced to it. We use it often in formulas. And so, let me show you how it works. It's going to have more than one variable, but you are going to identify one variable to solve for. And everything else, all the other variables, you will treat as though they are constants. So we're going to be going through this very deliberately. The first equation that we have here is A equals B times H. Notice I have three different variables. I don't know which one to solve for, so I must have this as part of my problem, solve for H. That means that the H is going to be treated as my variable, my typical X, and my A and my B are going to be treated just as though they were numbers. The most difficult part of the problem is remembering what you're solving for. So I like to circle the thing that is going to be my variable. So when I'm finished, I want H equals something. And all my other variables, the A and the B, are going to be on the right side of the equation. So this is a multiply here. It's a little hard to tell because of my circle. So this is going to have to go to that side. Okay. And so I'm going to first just rewrite this equation, flipping the left side and the right side. So I'm going to write B times H equals A. That'll be the easiest way to solve it. And I'm keeping in mind, again, I'm circling my H on each step because it's the H that I want to stay on the left side of the equation. The B, however, I want to move to the right side of the equation. Okay, so again, this first step, what I did was I flipped the left side and the right side of the equation, which I'm free to do, so that my variable is on the left. Now the B goes to the right. I'm multiplying right now. Let's say if I had 3x equals something, I would want to get rid of the 3 by dividing. So that's exactly what I've got here, except now I've got it looking like another variable rather than a number. But I will divide both sides by B, because right now I'm multiplying by B. So I'm going to be left with H, and I always like to keep it circled, equals A divided by B. And that's how you solve a literal equation. A literal equation does not have numbers in it. It only has variables. Okay, and we use these a lot in science and higher math. This would be the normal way we deal with things. Very few times do we actually have the numbers in there. So this is a very important concept. Let's do it again. It says C equals 2 pi r. And I'm going to solve for r. So I'm going to flip the left side and the right side. So what I'm solving for is on the left side of the equation. I'm going to copy the exact left side, or the exact right side over to the left side, equal, copy the exact left side over to the right side. And I'm going to keep track of the one I'm solving for. Now, just as if I had a 2, okay, on the left, like 2x equals something, and I would take it to the right by dividing. I'm going to take this to the right by dividing. I'm going to do it in 2 steps, but you don't have to. I would then get pi r, still trying to solve for r, equals c divided by 2. Okay, and then I also need to take that to the other side by dividing, and so then I would get r equals c divided by 2 pi. Now, probably the better way to look at this, let's look at it one more time, Again, flip the sides, solving for r. And then I'm going to just view this as one single unit. I'm multiplying the r by this, so I'm going to divide both sides. Divide, as I take this to the other side of the equation, I'm going to divide by 2r. And that's really the way I would tend to look at it, and that's a little easier for you. So let's do several more of these before you're going to be going ahead and solving them also, but I want to walk you through at least a couple more, and then you can see how you do with them. On number 4 here, it says P equals 2A plus 2B, and I want to solve for A. So, because I want to solve for it, I'm going to take this to the left side of the equation. I'm going to subtract this, just as if I had 2x plus 7 equals whatever. And I would subtract that. I'm going to subtract this. I'm going to be left with 2a equals p minus 2b. And then I'm still trying to solve for my a. So I'm going to need to take away the 2 by dividing both sides. So if you understand the process that you've been doing all along, this will look simple to you. If you're somewhat familiar with how to work with numbers, but you have not been doing this methodical approach, this will become a little more complicated. Let's do one more. Let's do 6. F equals mv divided by t. And I want to solve, in this case, for the v. So again, it's on the right side of the equation. I'm going to move the whole right side to the left side. Now, if I were dividing, let's say I had x over 3 equals 17, and I wanted to get rid of something I was originally dividing when I moved it. Should use a circle there. When I use that 3 to the other side, I'm going to be multiplying. So with this t, when I take the t to the other side, I'm going to multiply. So now I get mv, still keeping track of my v, equals f times t. See that? The opposite. It was dividing, now I'm multiplying. And finally, I need to get rid of my m. I'm multiplying now, so I want to divide. And I should get f times t. That doesn't stand for foot. That's just f times t over, I'm going to divide by m over m. And that's my answer there. Okay, so go ahead and try to work all your problems and see what you can get. Be very careful with them, paying attention to the order. Now, the second idea in this chapter has to do with solving inequalities and graphing. Now, we've done this many, many times, but let's go over a few more. 3r squared minus 18 is greater than 3r times r minus 3. Okay. I would distribute on the right side, and I'm going to get 3r squared minus 18 is greater than, again, you're writing all this down, 3r squared minus 3 times 3 is 9r. Okay. Notice if I have something on the left and the right side, I can just cancel those out. Why is that? Because I could subtract the negative, I subtract 3r squared from both sides as I bring it to the left, and 3r squared minus 3r squared cancels out. So you can just do that. Now, I like my variables to go to my left and my numbers to the right. So the opposite of subtracting is adding. The opposite of subtracting of my 18 is adding. To divide by 9. and I get R equals 2. Oops, why did I do that? I made a very common error here. Did you see it? Let's pause and look at that. My error was this equality. In fact, one of you did this on the quiz. Okay, that should have read 9R is greater than 18 and R is greater than 2. I did not have to change the sign because I did not multiply or divide by a negative. So be very careful, don't do my mistake there. Okay. Let's look at number 14. Here's the problem, and I don't see too much complicated about this problem, so I would like you to pause it, try to solve this one on your own, and then put your tape back on to check your work. Okay, the only thing tricky when you get to this one is when I go to this last step and I am dividing by a -6, I want to make sure I flip that. Negative divided by negative is a positive, and 18 divided by 6 is 3. Now let's look at a couple of the word problems. Go ahead and write this also. This would be 22 as an example word problem. Again, on page 36, it says Justin solved 14 problems, or 7/8 of the problems in his lesson. How many problems were there in his lesson? Okay, so there's a couple ways we can do this, and probably the most straightforward is 7/8 of the number of problems equals 14. That's how many he solved. He solved 7/8 of the problems. So to solve this, I would simply multiply by the reciprocal. So you undo a fraction, 14 times 7/8. Recall this is like that. The whole number always goes with the numerator. Let's see if we can do any canceling. Let's see, 2 goes into that, 4 times 2 goes into that, 7 times, and we get 49/4. Wondering if you caught my error. I just erased that. I'm actually trying to multiply by the reciprocal. So x equals 14. The reciprocal of 7/8 is 8 7. So the 8 goes in the numerator, the 7 in the denominator. 7 divides into 14 2 times, and x equals 16. So let's make sure it makes sense. Okay, he solved 14 problems. How many problems were there? There were 16 problems in all. Okay, so that's a good way to solve that. There's your equation. Notice I take my equation and I go through my steps until I get my answer. I don't want you to write an equation and then start guessing and plugging in. That will from now on be full marked off. So make sure you're using your equation to solve it. Okay, 24 says Mr. Sanders has $25 to buy roses for his wife. How many roses can he buy if each rose costs $1.50 and there's a $3 fee? Okay, so the number of roses that he can buy is going to cost $3 plus $1.50 times the number of roses. And I want that to be less than or equal to my $25 because I can't spend more than that. Okay, so that's why I would say it's less than or equal to. So how would I solve this? I'm going to solve for r by subtracting 3. $25 minus 3 is 22. I'm going to divide by 150. Notice I am not dividing by a negative, so I leave my inequality in the same, and $22 divided by 150. If I do the division either on a calculator or longhand, if I did it longhand, of course, I would just say 2200 or 22, right, divided by 150, pulling my decimal place over 2 places. And then, of course, I would tend to look at this actually with dividing these out, and if I did that, I would get 14.6. Now I can't buy a part of a rose, so my answer would be that I could buy 14 roses and I'll have a little bit left over. Okay. So you do go ahead and do the rest of the word problems on your own, and then we'll look at the next page, we'll look at the new lesson. Now in 1.10, they give you a bunch of formulas for geometric shapes at the top, so I'm not asking you to memorize those, although they are pretty easy to illustrate why they're such this way, some a little easier than others, but they've given you the formulas, so you just use them, okay? The only ones they haven't given you perhaps are very easy ones. So let's look at a couple of these. It says, let's do number 2, I'll do the even ones. What is the perimeter of a square? Well, he doesn't give you the perimeter of the square, but perimeter is, recall a square would have the same distance on the height as the width, and perimeter is going all the way around. So the perimeter of a square is 4 times x. So what is the perimeter of a square, each of whose sides is 2 1/4 a feet? Okay, so the x is 2 and I want to substitute in instead 4 times 2 1/4 a. Okay, so it looks a little odd. Okay, so how would I do that? Well, I'm going to go ahead and multiply. Now to multiply, I need to change the mixed. So you're going to say to an improper 9/4. Now, 4 times 9/4, notice the 4s will cancel out, and I'll get 9a. So the perimeter is 9a. So these become substitution problems using the correct formula. So let's do one more. I don't think you're going to have a lot of trouble with these. A piece of glass is in the form of a trapezoid. The longer base is 2.5d inches. The shorter base is 1 1/4 d inches, and the altitude is m inches. Okay, let's look at that. So I would draw myself, that's a very poor looking trapezoid, I apologize, but my height would be here. My short b would be there, my short length and my long length would be there. And it says the longer base is 2 1/2 d, so that's this. And the shorter base is 1 1/4 d, so let's go ahead and start plugging in, and the altitude, which is the height, this would be the same as the altitude, and that is m. So now plugging in my 3 values, I'm going to get 2 1/2 d plus 1 1/4 d, and now I'm going to solve it. So this becomes 1/2 m. Solving it, 2 1/4 plus 2 1/2 plus 1 1/4 is going to be 3 3/4 d, which if I wrote that as a improper, which would be the better way to do it, that would be 12 plus 3 more is 15/4 d. Okay, and so now the last step, this is always area, equals this, and so 1/2 times 15/4, I cannot cancel, that would be like 1 times 15 over 2 times 4, right? md, or dm if I want to do it in alphabetical order. These can't cancel, so that would just be 15/8, and I'm very happy to have you leave it in improper fraction form. That's actually my preferable form. Okay, and that's all there is to it. And then you put your units in when you have, so these would be area, so it's square inches. Okay, so again, you're identifying, you might find it helpful to draw a diagram, you identify the formula you need, you figure out what plugs in where into the formula, and then you solve it. So go ahead and work on those, work on the word problems, and the check for progress 1 and 2. Make sure you have those done. We're getting ready, of course, to ramp up for the test here, and there should be no review you need for those. I want you to work the word problems by yourself, and then we'll correct any as we need to once we go over the answers. Okay, I will also be posting Lesson 7A homework corrections, so be sure to look at those.